Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Over in this video, we're going to talk about how we can verify some trigonometric identities. So the purpose of this video, or what we mean by verify, is we want to make the left side of the equation look like the right side of the equation, essentially. So we're going to use some identities that we know and try and rework the expression on one side to make it look like the expression on the other side of the equation. And if we can do that, then we've verified that it's true. All right, so let's look at number one. We have 1 over secant theta minus tangent theta is equal to secant theta plus tangent theta. So I'm going to take what's on the left side, 1 over secant theta minus tangent theta, and I'm going to try and make it look like the right side. So let's simplify, use some identities so that it ends up being secant theta plus tangent theta. So what I'm going to do is take my denominator, secant theta minus tangent theta, and I'm going to multiply by what we would call the conjugate, right? So I'm going to multiply by secant theta plus tangent theta over secant theta plus tangent theta. So I can do that because it's essentially just multiplying by 1, right? So now my numerator will just be secant theta plus tangent theta, and now my denominator will we'll use the sum and difference pattern, right? So it'll be a squared minus b squared. So we would have secant squared theta minus tangent squared theta. So now if we think back to an identity that we know that 1 plus tangent squared theta is equal to secant squared theta. All right, and these identities that I'm referring to, I made a separate video just kind of going over all the different identities that we can know and use to help us simplify or verify trigonometric expressions or identities. So I'll link that in the cards right now if you want to go and check and see where these identities are coming from. Okay, so now let's say I subtract tangent squared theta here. So subtract tangent squared theta. So look what happens. This expression, which is in my denominator right now, is equal to 1. So this essentially just becomes secant theta plus tangent theta, which is what we were trying to get. So we'll give it a check mark. We verified number 1, okay? All right, let's take a look at number 2. Secant squared theta minus 1 divided by secant squared theta is equal to sine squared theta. So we're trying to make the left side become sine squared theta. So what I want to do is I want to take my fraction here and basically separate it. So I'm going to write secant squared theta over secant squared theta minus 1 over secant squared theta. So if you notice there on the left, that's just going to be 1, right? Secant squared theta divided by secant squared theta. So now we have 1 minus 1 over secant squared theta. So what I notice about secant squared theta is if I could pull out the square, then I would have 1 over secant of theta, which would be just cosine of theta, right? So we could say 1 minus 1 over secant theta, and I'm going to pull out my exponent of a 2. And now this would be 1 over cosine of theta squared, and this would be 1 minus cosine squared of theta. So an identity that we know that sine squared theta plus cosine squared theta is equal to 1. So if I subtract cosine squared theta from both sides, then look what we get. We get sine squared theta is equal to 1 minus cosine squared theta. So we have 1 minus cosine squared theta right there. Our identity tells us it's equal to sine squared theta, and that's what we are trying to make it be equal to. So we'll give this one a check. We have verified number 2. Okay. All right, we'll do 2 more. Number 3, we have sine of x over cosecant of x. So in this case, we're just replacing theta with x, plus cosine of x over secant of x equals 1. So we're trying to make the left side become 1. All right. So let's take sine of x over, and instead of cosecant of x, let's write that as 1 over sine of x. So 1 over sine of x. And let's follow that same pattern, and instead of writing secant of x, let's write this as 1 over cosine of x. So now it looks a little bit weird. We have a complex fraction, so let's write that as multiplication. So this would be sine of x times sine of x over 1 plus cosine of x times cosine of x over 1, right? We're just basically using KFC, or keep, flip, change, to keep our first fraction, or sine of x, and then change division to multiplication and take the reciprocal of 1 over sine x and 1 over cosine of x. So now we're going to get sine squared of x plus cosine squared x. All right, well, we've seen that identity a couple different times. We know that that identity tells us that it's equal to 1. So sine squared of x plus cosine squared of x is equal to 1. So that's what we have here. We're trying to make it be equal to 1. It is equal to 1 according to our identity. So we can give that one a check. We did good. We verified number 3. Okay? All right, last one, number 4. We have secant of x plus tangent x is equal to cosine x minus, or divided by 1 minus sine of x. So let's take secant x plus tangent x and try and make it be equal to cosine of x over 1 minus sine of x. Well, we know secant of x would be 1 over cosine of x, and tangent of x is sine of x over cosine of x. So sine of x over cosine of x. Okay, so now if we put those together as one fraction, we would have 1 plus sine of x over cosine of x. So similar to what we did on number 1, let's multiply by the conjugate here. So let's do 1 minus sine of x over 1 minus sine of x. So in the numerator, we have our sum and difference pattern. It's going to end up being a squared minus b squared. So this is going to give us 1 minus sine squared of x. Now in our denominator, we can look at that and say, okay, that's just going to be cosine of x times 1 minus sine of x. And I could distribute that, but I'm just going to leave it separate right now, and it'll make sense in just a minute. Now my numerator says 1 minus sine of x. Well, if I go back over here to number 3, where we had sine squared of x plus cosine squared of x, we said that was equal to 1, right? Well, what we could do is, what if I subtracted sine squared of x? Okay, so I have sine squared of x plus cosine squared of x is equal to 1. Well, what if I subtract sine squared of x to basically solve this for cosine squared of x? So sine squared of x. So I'm going to get cosine squared x is equal to 1 minus sine squared of x. So notice my numerator is 1 minus sine squared of x. So basically I could rewrite this as cosine squared of x, because that's what that expression is equal to, over cosine of x times 1 minus sine of x. And now notice I have cosine squared of x in my numerator, and I have one factor of cosine x in my denominator. So one of the factors in the numerator will cancel with my one factor in the denominator. So the numerator will become cosine of x, and my denominator will just be 1 minus sine of x. So we end up with this, and that is what we are trying to make the left side be equal to. So we have proved it, and we have now verified number 4. Okay, so that's how you can verify some trigonometric identities.